Hello and good morning, CTS231 Section 875 students for the second 8-week term in the fall 2016 semester at Anne Arundel Community College. This is the CCNA Networking 4 course, or the Connecting Networks course as the title of the book is, from Cisco Networking Academy. And this morning's video tutorial is going to be on PacketTracer Activity 5.2.1.4 from Chapter 5, where we take another look. We already took a look at this in the Routing and Switching Essentials, but now we go a little deeper dive here with configuring NAT, or Network Address Translation. And keep in mind that NAT was a convention that was really created in order to sort of slow down or try to halt the depletion of the publicly routable IPv4 addressing space. And as you probably know, I think it was January of 2011, the last blocks of IPv4 addresses were actually allocated out to the different regional registries. So IPv4 addresses have been all handed out. They've pretty much been depleted in terms of the allocations. I'm sure that some of the regional internet registries have some available blocks of addresses, but in terms of being allocated, everything has been allocated out. And that's why you see a push now toward IPv6, and kind of moving forward, that's what everyone's going to be trying to do anyway. IPv4 is definitely going to be around for a while. It's not going to disappear anytime soon. And that's really what NAT was all about. NAT was created, if you look at the diagram that we have here on the left-hand side. So if this is my enterprise here, right? So this is my router. I'm connected to the internet. And I've got a switch back here. And let's say that I decide that I'm going to use 172.16.16/28. Now remember, with a /28, how many bits have we ended up borrowing here? Or I should say, how many bits are left in a 32-bit IP? So there's 4 bits left. So if I was to say 2 to the 4, there's 4 host bits left. So 2 to the 4 minus 2. 2 to the 4 is what? 2 times 2 is 4. 8, 16 minus 2. So we've got 14 usable IP addresses back here on our network. And so since our network ID starts at .0, we know that the network goes from .0 to as the network ID. The block size is 16, so that takes me to .15. So in between there, the .1 to the .14, these are going to be my usable addresses. Now, there's one major problem here with the address space that I'm using. So you can see we've got a publicly routable IPv4 address out here on the outside interface of the firewall. However, in here I am using private RFC 1918 addresses, right? That 172.16 block, or the 10, ironically they have it over here, the 10 block over here, or the 192.168 block that's over here. So we're using RFC 1918 addresses. Well, in order for these addresses to route on the public internet, they need to be natted, or translated into a non-private RFC 1918 address. Or in other words, these inside local addresses, I'll put IL here for now, these inside local addresses need to be translated to inside global addresses. So let's go ahead now and get everything configured up here. We'll take a look at the activity on the right. So we're going to test access without net. So from PC1, let's go ahead and pull PC1 up here, and let's see, can we ping from the desktop and the command prompt? Am I able to ping server 1 at 172.16.16.1? So let's go ahead and give that a try. So ping 172.16.16.1. Again, I'm trying to ping across the internet to an RFC 1918 address. And that's what we should see, is we're going to see that it doesn't work, because most providers on the internet will have ACLs set up in some form or fashion that are going to block those private RFC 1918 addresses from being routed over the internet. And that's why we refer to those as private. They should not be leaked out onto the internet. So now from PC1, let's try to ping the R1 router's serial 000 interface. So let's actually get router 1 up here. Let's figure out what that interface IP is going to be. So we'll stretch this out here. We'll come to the CLI. And let's get into privilege exec and say show IP interface brief. So we can see that the IP is a publicly routable 209. So let's go ahead and say ping 209.165.128.130. And as you can see, we do have connectivity to that .130 address. And again, because this is a publicly routable block of addresses. Okay, so we've done step 1, right? We've checked to make sure that the pings don't work to the server, but do work to that outside interface of the router. So now we're going to view the R1 routing table and the running config. So let's go ahead and make sure we have no NAT commands on here. So if I say show run, you can see we've got some spanning tree, the interfaces are configured, and that's pretty much it. What about a show IP route? So I just simply have my directly connected entries. So it's definitely show Ip Nat Translations. So NAT is definitely not configured here on the router. So now we're going to configure Static Nat. And it's basically Static Nat of the 3 different types of NAT that we're going to talk about. We're going to talk about Static Nat, we're going to talk about Dynamic Nat, and then we're going to talk about NAT overload, which is also referred to as PAT, or Port Address Translation. So remember, those are synonymous. It's that, in other words, NAT overload and PAT are the same thing. It's just that there's 2 different ways to refer to that same concept, which is we're going to be using either one or more publicly routable addresses, but we're going to be using the source and destination IP and port numbers in order to sort of create a better scaling scenario than we would with just dynamic NAT, because those port numbers give us about 65,000 possible connections that we can use. All right, so again, Static Nat is probably the easiest NAT to configure, and we're simply going to configure a Static Nat setup here, and let me try to bring this down a little further. There we go. We're going to do a Static Nat setup here so that the inside local address of 172.16.16.1 has an inside global address of 64.100.50.1. And so we're on part 2 right here, configure Static Nat. So we need to configure our Static Nat statements. And again, static is very straightforward. So we're basically just going to say, Ip Nat. Now, are we talking about an inside address translation or an outside address translation? Well, remember, we're translating this inside local, right? And so we didn't do pool. Remember that the pool is going to be when we do a dynamic NAT configuration, or you can use a pool with a NAT overload or PAT configuration as well, port address translation configuration. So Ip Nat inside. So what's my source address? 172.16.16.1. And then what is my, oops, sorry. Need to get source in there. I got ahead of myself. So source static, and now we need to go ahead and put the address in here, 172.16.16.1. And what is the inside global address? So it's kind of tricky sometimes, right? So the inside global, it's all kind of in terms of your perspective, right? So from the perspective of server 1, this is my inside local address, and this would be my inside global address. In other words, what address out on the internet are people going to see me as? Or if they're trying to get to me, what are they going to be using? Well, it would be this 64.150.1. So we'll go ahead and drop that in here. So 64.100.50.1. And that is it. It's literally that easy to do Static Nat. Just Ip Nat inside, source static, and then my RFC 1918 private inside address, inside local address, and then the outside local address to which I want this address to be translated to not only when connectivity is going outbound, but typically you do static NAT when you want continuity when you have connections coming from outside of your enterprise. So if I were to do this here, right, and let's say that this is company A. So if this is company A, and company A has this server, if for whatever reason, and unfortunately they're using these RFC 1918s out here, but let's suspend reality for a second. Let's say that these weren't RFC 1918s, because they wouldn't be coming over the internet like that. So, but let's say that this is, you know, a work from home guy, so WFH, he's working from home, and this guy over here is working from home as well, and they're trying to get access to this server. They're never going to get it going to the 172.16.16.1. They need the publicly routable IP. So like, let's say that he decides he's not working from home, he's in a hotel somewhere. They can come over the internet, but they need to make sure that there's continuity in getting to the 64.150.1. And that's what Static Nat is all about. It guarantees a one-to-one relationship between the inside local and the inside global. And that is not the case when we talk about dynamic NAT. And it is certainly not the case when we talk about NAT overload or port address translation, PAT, where you do not have continuous one-to-one relationships between the inside local and the inside global. So again, think of it like this. If this was my web server, right, would you want your web server address to possibly change, the public address that people are going to possibly change in an ad hoc fashion? No, you wouldn't. So you would use Static NAT to guarantee a one-to-one relationship that's not going to change unless someone comes in here and actually changes it. Then you would be able to hit your web server without any problems. Now, if we were using dynamic NAT, sure, the server is going to get a publicly routable IP from a pool of addresses, but there's nothing that says that that pool of addresses, that you're going to have that same address every single time. What if that address gets taken by another box, and then you've got web requests that are coming in looking for the 64.150.1, and it turns out that maybe it's somebody, somebody back here with a PC, that now you're hitting that PC. So this is what Static NAT is all about. One-to-one, right? One RFC 1918 address here, one private address that corresponds to a single public address. So let's go ahead and drop this in here. Whoops, bring that back. Let's go ahead and drop that in there. And there is our Static NAT statement. So now let's go ahead and we can actually see this. So do show Ip Nat Translations. And there we go. Now, you'll notice the protocol, it's got these dashes. And so does the inside local and outside global. Now, this is because this is a static entry. This entry will be in this table, this NAT translation table, permanently. In other words, it's not a transient entry because it's showing that we've created this static NAT translation and that it is not going to go away. And that's why I said there's continuity, is that it is not going to simply just disappear. So let's say show Ip Nat Statistics. Is anything going on? How about do show Ip Nat Statistics? So we don't have anything yet, right? But we will shortly. So let's now go ahead and we created the NAT statement, configure the correct inside and outside interface. So now what we want to do is on the router, we need to tell the router which interfaces are the inside interfaces. In other words, where am I looking for those private addresses on the inside, and what is my outside address? Well, it's pretty simple. We'll say do show IP interface brief. We can see that gig 00 is clearly the inside private addressing, and serial 000 is the outside public addressing. So let's get an interface gigabit Ethernet 00, and you simply say Ip Nat inside. That's it. And then we get into serial 000, and we say Ip Nat outside. So we have to tell the router which interface is the inside interface and which interface is the outside interface. so that it knows when it's looking at the translation table which interface should it be seeing the inside local address on for the inside interface, and which interface should it be looking for that inside inside global address, which would be our outside interface. So now we'll say do show Ip Nat Statistics. Do we have anything going on yet? Nope, we just have one translation and it is static. And then here we see that's the outside interface is serial 000, the inside interface is gig 00. No hits, no misses, no expired translations. It's never going to expire because it's in here permanently. Remember, it's static. And the dynamic mappings, right? There's nothing to speak of here because we're not doing dynamic NAT. So what we should do now is let's go ahead and test connectivity here from the PC again. And we're going to try to get over to... Let me make sure that that's what they want. Yep. Okay, so we're going to go ahead and try to ping the 64.100.50.1. And let's see, can we get to the 64.100.50.1? We probably have to ARP out here for the first request, but then take a look, right? We've got connectivity now. So if I were to run it again, there we go. Now remember, initially I was pinging this inside address, proving that, we can't get across the internet. So what if I try to ping that address now? Is it going to work? No, it's not going to work. It still doesn't work, right? Because we're translating that private address to a public address on the router 1. So the 64.100.50.1, that's the address we need to be pinging. That's the address that we would try to connect to. So if we were, and again, right now, you can see we don't have a firewall in the configuration here. So, from this perspective, we've got full-blown access from the internet into server 1 if people know the IP address is 64.100.50.1. But now let's come back and take a look at the translation table. And let's look at the stats table first. So you can see, and again, it says expired translations 3 because we had pings that were coming through that now those are no longer coming through. So 11 hits, 12 misses, right? And you can see here that we've got total translation, 9 dynamic, 9 extended. Now, I'm not confident if I were to say do show Ip Nat Translations. So you can see here that we end up with a listing of the inside global, right, which is the publicly routable IP, and the inside local. And this is showing the sequence number, right, 23, 24. So if I were to ping again, watch what happens. And you can see right here again, this entry is not going anywhere. So it's keeping track. So there we go. So we pinged 5 more times, or what was it, 1, 2, 3, 4 more times. So it went from 24 to 25, 26, 27, 28. So these entries here are going to be transient. It shows me who's coming through. But again, this entry at the bottom, that entry is not going to go away. That entry will always be here until we remove that static statement that is creating this relationship here. So one more time, do show Ip Nat Statistics. And you can see that when we see these expired translations, it's talking about these transient entries that were coming through. Hits and misses, looks like we had a 16 misses, but we had 15 hits. And again, and this is interesting here, I did not expect to see the 4 dynamic 4 extended. It's got to be referring to those 4 ping packets right there. In fact, I'm wondering if I can get away with, if I ping, if you can say, I don't think you can say this here on the PC. Yeah, you can't say that on the PC. I was going to see if it dropped it down. But this, again, is Static Nat. Very, very simple, very straightforward, a single statement. And let's take a look at that. Do show run. And it's a 1-to-1 where we simply say Ip Nat inside source static. All right, well, this is going to wrap up PacketTracer activity 5.2.1.4. Again, kind of easing us into network address translation by taking a look at Static Nat. The next activity that we're going to be looking at, I believe, is 5.2.2.5, where we're going to be configuring dynamic NAT. All right, thanks for watching, and I'll see you guys this week.